All right, let's go ahead and get started. Well, thank you for joining us for this inspiring conversation with a few of our leading Laurier researchers, all of whom are working closely with local governments and Indigenous communities to tackle the impacts of climate change across Canada's north. Before we get started here, I just want to take a moment first to acknowledge that Laurier's campuses are located on the traditional territory of the Anishinaabe, Haudenosaunee, and Neutral peoples. And perhaps you're joining us from another location, and in that case, I'd encourage you to take a moment to honor the Indigenous people who've lived and worked where you reside. And acknowledging them reminds us of our important connection to this land where we live, learn, and work. So my name is Brandon Walker. I'm a senior research associate here at Wilfrid Laurier University, where I'm the manager of the Arctic Hydrology Research Group, as well as the Trail Valley Creek Research Station located in the Western Arctic. I spend a lot of my time conducting fieldwork in the tundra, close to the Arctic Ocean in the Northwest Territories. I actually just got back last night from a field campaign, and it was quite chilly. So I've been working with in the north in some capacity with Wilfrid Laurier University since 2014, where I started as an undergrad student. And I've had the opportunity to continue in this program, both as a student, as a grad student, and as a full-time researcher. And so I've got to see a lot of Laurier's research in action across the north, and it's been quite impressive and encouraging, which is why I've continued on. So for those of you that don't know, Laurier has a strong research presence in Northern Canada, where we maintain more than 50 research sites, a dedicated research office located in Yellowknife, Northwest Territories, and we have a long-standing partnership with the government of the Northwest Territories, which all of this sort of helps drive Laurier's involvement with northern communities and northerners to try to understand and tackle problems relating to a changing climate. And if you are not aware, a lot of this interest stems out of the fact that the Western Arctic and the Northwest Territories are some of the most rapidly changing places on Earth, where climate change is 3 to 4 times that of the global average. And so these landscapes are changing very rapidly, and the ecosystems are changing rapidly. And so a lot of our research goes into try to understand this, both for the global and regional impacts, but also for that of local community members there. So today we're going to have the pleasure of hearing from 3 of Laurier's leading northern researchers. At first, we're going to hear from each of these panelists about their ongoing work in northern communities, after which we'll open a discussion and have some time for conversation from our panelists and the audience members as well too. So if you have any questions along the way, feel free to type them in the Q&A chat, and I'll relay them to our panelists after they speak, and we'll have some time for just an open discussion. So first to begin, I want to introduce our 3 panelists we have today, Dr. Jennifer Baltzer, Dr. Homa Kheyrollah Pour, and Dr. Miguel Sioui. So Dr. Jennifer Baltzer is a Canada Research Chair in Forests and Global Change here at Laurier. Her work focuses on the drivers of forest composition, structure, function, and responses of these systems to global change. She's worked in a wide range of systems, ranging from the tropics to the tundra, which is actually how I met Jen many years back. And she currently leads an extensive boreal forest research program throughout the Northwest Territories and Western Canada. Jen's interdisciplinary research program examines the impacts of a warming climate and associated changes such as permafrost thaw, wildfire regimes, and biome shifts on the distribution and function of high latitude boreal forest systems, and what kind of implications these might have for northern communities. Our second speaker is going to be Dr. Homa Kheyrollah Pour, and she is a Canada Research Chair in Remote Sensing of Global Change here at Laurier. She studies the responses of cold regions hydrology to a changing climate, where her work looks to understand changes to lake ice, snow cover, and land cover, and she incorporates satellite observations, as well as field observations of surface and subsurface processes, and couples that with numerical models to try to understand and predict change. Homa's current areas of interest include development of machine learning and statistical modeling techniques to understand the relationships between ice extent, environmental drivers, and water quality, and the response of all of these to northerners, whether it's through lake ice or ice roads, and look at how these are either have changed or will change under projected future climate warming conditions. And finally, our third speaker is Dr. Miguel Sioui, and he's an associate professor here at Wilfrid Laurier University in the Department of Geography and Environmental Studies. Miguel, as an Indigenous geographer and environmental management scholar who's deeply rooted in his Huron-Wendat traditions and community, he looks to bridge the gap between the two worlds of Western science and Indigenous knowledge that have historically struggled to maintain some meaningful communication. So Miguel's current research seeks to bridge Indigenous and Western academic epistemologies to foster Indigenous and Western academic management strategies that are more likely to promote responsible and respectful relationships with the environment over the long term. And so with that, with the introduction of our three speakers here, I'd like to turn it over to Dr. Jennifer Baltzer, who's going to share a little bit about her research program in the North.
Thanks, Brendan. Okay, let's see if we can get this sharing properly. All right, can you see that okay, Brendan? Great. All right, so, hello, everyone. Good morning. I'm actually joining you from Yellowknife. I'm up here for some meetings with community and government partners over the next few days. And I'm going to share a little bit of work that we've been doing about changing wildfire in Canada's north, and some of the work we've been doing to understand the implications of that. Okay, and before I get started, the work I'm presenting is a really big collaborative effort with many different students and postdocs and researchers, and you'll see some lovely faces throughout the presentation of students who led the work. So, you know, if I say I probably mean we. If I say we, I probably mean they. You know, the hard work in any of this is done by, typically done by students and postdocs, and just like to acknowledge their big contributions. I'd also like to acknowledge the fact that the work I'm presenting was conducted on the traditional territories of a number of different Indigenous groups in the Northwest Territories. The wildfires that we've been studying impacted the Decho, Quechua Northwest Territory, Métis Nation regions, as well as the Sahtu region, and some of the work that I'm presenting today is coming from many of those locations. I'm also just being informed by my computer that my internet is unstable, so I apologize if I get choppy. All right, so wildfire in the boreal, and hopefully this works. There we go. Wildfires are a really natural and important part of boreal ecosystems. It's the primary disturbance agent in boreal forests, and it's really critical for renewal in these systems. We see lots of amazing adaptations of boreal species to this type of wildfire. In the Northwest Territories, wildfires happen every 70 to 100 years. And so it's a really frequent disturbance. The pictures you see here on the left-hand side of the screen are black spruce cones. The bottom one is a black spruce cone closed up and coated in resin. Black spruce are what we consider serotinous. And so as the heat of the fire moves through, that waxy coating that holds the cone shut melts away, and the cone opens, releasing seeds onto the fresh seedbed and allowing black spruce to self-replace. So we have all kinds of amazing adaptations of these northern species to this particular disturbance regime, allowing the system to be resilient to that kind of seemingly catastrophic disturbance, but really an important renewal agent. The challenge comes when we think about a changing climate, and high latitudes are warming fast, in fact, about 4 times faster than the rest of the planet. And this has big implications for all kinds of processes in Northern Canada, and we'll hear more about that from Homa and Miguel, I'm sure, later on. From a fire perspective, a warming climate means changing wildfire activity. Here we have a graph. I mean, many of you will have noticed headlines in the newspapers year after year talking about, you know, unprecedented or record-breaking fire events, lots of, evacuations of communities, all of these kinds of impacts of wildfire. And part of that has to do with the fact that we're seeing this increase in fire activity across the decades. So here we have from 1960 up to nearly present day, and this sort of continual increase in the total area burned. This goes hand in hand with increase in frequency and severity of wildfires. So overall, we're seeing a changing fire regime with the warming climate, which leads to a drying landscape. The summer of 2014 was a particularly large fire year in the Northwest Territories. About 2.8 million hectares of forested land burned in this particular fire. And here you see a picture taken along Highway 3, the road out of Yellowknife, and it burned, both sides of the highway. And as you're driving out of Yellowknife now toward Fort Providence, it's just, the entire landscape, much of the landscape along that road is burned. And it caused all kinds of problems, from huge amounts of smoke, as you can see from this picture, to road closures, restricting access to and from Yellowknife, lots of impacts on communities, evacuations of communities, in fact. And so it was a really big fire year, and lots of concerns came out of that. And here are a few of those. So we spent a lot of time meeting with government and community partners to figure out, okay, well, what are you worried about after this, really unprecedented fire year? And some of the questions that came to light were concerns about carbon stocks. How resilient are those carbon stocks? How much carbon are we losing from this landscape when we have these big fire events? Will the forests recover to what they were before the fires? What will they look like after these severe and deep burning fires? And what's the impact on wildlife, particularly caribou? So in response, myself and all of those many collaborators that I showed you at the front of the talk set up a territory-wide, fairly widespread network of forest plots, ranging in sites that from those that burned in 2014 to much older sites that hadn't burned in quite a long time. So the darker the color on these patches, the younger the burn. And you can see what a mosaic of fire ages the Northwest Territories contains. So fire, you can see it's touched pretty much every part of the landscape in the last, since the 1970s, let's say. And so we set up this network of sites and to address those particular questions. So first of all, I'll start on how resilient are carbon stocks. Within those sites that we established, we sampled a lot. We collected a lot of information on carbon. We both collected information on how much carbon was burned away. Trees produce these amazing little adventitious roots that give us a marker of where the fire was before fire. So we actually quantify and reconstruct how much carbon was burned away during those fires. And then use different landscape attributes to scale that to the whole landscape. So we were able to come up with estimates of how much carbon was released during these big fires in 2014. And you can see a map of it here. And it was really variable. Some places burned really severely, other places burned much more lightly. But when we look at the whole picture of all of the fire scars and these scaled up estimates, it equated to 94 million metric tons of carbon dioxide that was released during that fire event. To put that is a number that most of us can't even envision, but to put that into context, it's about half of all of the carbon dioxide absorbed by Canada in a given season for all of its ecosystems. And so when we're thinking about, contributions to the global carbon balance, these are really important events that we need to better understand. The other piece we were really interested in is, are we losing old carbon from these landscapes? The boreal forest is a really important carbon sink. It has been for a very long time. And the way that happens is through accumulation of carbon in soils. And so if we have a fire, you have a fire that burns through, and then you have some fire-free interval where trees establish and the peat mosses grow back. And lots of carbon is sequestered that way. Then you have another fire. It consumes, it'll kill the trees and consume some of that organic soil, but not all of it. And so that older soil gets buried by the new peat soil that accumulates on top. And so you can see as we move through time, that old carbon or legacy carbon is accumulated and increases. And this is part of how the boreal is such an important carbon store or carbon sink. Now, what we found is that with shorter fire return intervals, some of that sink capacity was lost. So in the event of short fire return intervals less than 60 years, we saw complete combustion of all of the new carbon that had been laid down in the previous fire-free interval. And we actually saw that fire gobbling up some of the older carbon from previous fire-free intervals. So this is really worrying when combined with the huge amounts of carbon that are released from a big fire event like this. This is really concerning from the perspective of the boreal as maintaining its ability to act as a carbon sink. Second question is, will forests recover to what they were prior to the fire? Now, this looks like a complicated figure, but again, in each of these sites, we counted tree seedlings. We looked at how many seedlings have recovered and what was the stand composition before fire. And so each of these arrows represents one site. The tail is what it was before the fire. The head is what it was after the fire. When we have a long arrow, that means a big change away from the pre-fire forest composition. When we have a short arrow, it means a small change. And what we see, so first of all, most of our sites were dominated by black spruce. It's the most widespread and dominant species in the boreal forest. And in many cases, both on the Taiga Shield, so this is a Canadian shield landscape, and the plains, so an adjacent kind of flatter, wetter region, black spruce showed a lot of transitions away from that pre-fire condition to something else. In the Taiga Shield, this was a shift toward birch, so paper birch. On the Taiga Plains, this was a shift predominantly toward jack pine and secondarily toward trembling aspen. And in fact, what we saw was that black spruce lost dominance at about 43% of sites on the plains and about 30% on the Shield. And this is really surprising given the fire-embracing nature of this species and that it has self-replaced through those mechanisms I've described over a very long period of time, thousands of years. We found that the drivers of those changes were pretty consistent. So places where we saw transitions from black spruce to jack pine or from black spruce to birch, those corresponded with places where we had thin residual soil organic layers. So where the fire had combusted much of that organic soil and maybe mineral soil was exposed. And the deeper that residual soil organic layer, so the lighter the burning, the less likely we were to see a transition from black spruce to jack pine or black spruce to birch. And the same held true for stand age. Where fire return intervals were short, where the stands were young, we were more likely to see transitions away from the pre-fire composition to something else. And so you can imagine if this was the pre-fire condition, these are two different endpoints. And you think about your favorite feature of a forest, your favorite function, and when you change species composition like this, those functions change, whether it's wildlife, whether it's carbon storage, whatever your interest is. So the outlook is that deeper, more frequent fires will lead to more frequent state changes. Finally, what's the impact on wildlife, especially caribou? To start to tackle this, we use data from across that full chronosequence, so stands that had burned recently right up to stands that hadn't burned for a long time, to look at the recovery of caribou, these beautiful lichens that form lovely mats on the forest floor, and they're really important forage for both boreal and barren ground caribou. And what we found is that different latitudes, so we sampled from Saskatchewan right up to into the Northwest Territories, different latitudes recovered at different rates. So more southerly latitudes recovered more quickly than more northerly latitudes, but also that different forest types recovered differently. So jack pine and black spruce were two really important forest types for accumulating high volumes of high biomass of lichen, as you can see by these higher lines in this graph. And we're now taking that information to try to scale it up to provide tools to support planning on the land in terms of caribou habitat. So Maria Belki-Brea is currently converting those models of lichen accumulation into a scalable product at the territory-wide scale. And she's doing this by combining these ground data with a range of remote sensing tools. And here you can see a first cut of her map with darker red colors being higher biomass areas, lighter, the yellow colors being lower biomass areas. And with that, I'm going to wrap it up, but hopefully that gives you a sense of some of the ways we've been trying to tackle some of the community and government related questions that about how the system was responding to these kinds of fires. And I look forward to our discussion later. Thank you.
Thanks for sharing, Jen. It was quite interesting. If you have any questions, feel free to type them in the Q&A chat there. We have a couple trickling in, and we're just gonna hold those off till we till the end here. Yeah. All right. So our next speaker, Homa, when you're ready, please take it away.
So can you see our screen? So my screen is good. Can you hear me well? Awesome. Great. Okay, good morning, everyone. So it's my honor. It's an honor to be here today and share my research with you all today. As Brendan introduced, so my name is Homa Kheyrollah Pour, a Canada researcher in remote sensing of environmental change. So my research group then entitled to Remote Sensing of Environmental Change, RESEC. So RESEC is 3 years old and so started in mid-2019. As it shows by the name, so we are using remote sensing observations as one of the main source of data to understand environmental changes, to develop predictive models and project the future. The overreaching question in my research group is how lakes are changing and responding to environmental pressure in this current and future warming climate, and more specifically in cold region. And with cold region, I mean lakes that partially froze during winter or fully froze during winter. So we work on lakes in Northwest Territories and also in Ontario, Laurentian Great Lakes. But what you will hear today is more focused on some of the projects we are working at Northwest Territories. So the question is if we do have enough observations to understand this ecosystem and changes, and if not, what should we do? So as you all know, Earth is getting warmer and climate is changing, and impact is increasingly serious and very dangerous. 150 years ago in 1850s, so the climate scientists first discovered that we are impacting climate by burning the coal and gas. So here you go after 150 years, so we are not changing anything. So. This graph, as you can see in right, is animated spiral, which present the global temperature changes from 1850 to 2020. As you can see, the pace of the change is immediately obvious. So, and it's actually over time. So you can see over the few decades that we are living in. As you can also see, the global temperature increased over 1 degree, and some seasons like winter, you can see it's more than 1.5 degrees. If you're wondering about the colors, present the time. So purple is earliest time, and when you go toward yellow and green and yellow, so it's more recent years. And here you can see the same graph in 3D version. So the third dimension represent the time. So obviously, Earth is getting warmer and it's getting warm fast. So we talked about the global scale. So what change in Earth in global scale might be different with the local scale or more regional scale. In upper graphs, you can see the global changes over time, and the lower one, you can changes happening in Canada. As you can see, in regional scale, we have more variability compared to the global scale. This variability is important for us to understand. It's why we actually research the regional scale to understand and better understand the global scale changes. So, and among all this season, the warming is most pronounced at higher latitudes and during winter, as you can see in this graph. So as a result, ice condition up north, over land, over lake, over sea, will change with very high rate. So this is profoundly affect the hydrological function and ecosystem up north that I'm sure all of you know. So far we just look at where we are at. So, but next is what comes next. So the future projection. It's projected that winter mean temperature here in Kitchener-Waterloo area will increase by 2 degrees and annual precipitation will increase by 6%. Till 2095. So it's a lot. So now we are in Waterloo, Ontario. Let's move up to Yellowknife and see what is a projection for Yellowknife. So higher the latitude, more the change. In Yellowknife and WT, it's projected winter mean temperature increase more than 3 degrees and precipitation increase by 11% by 2095. So more rapid changes up north. It's projected that the number of days over 30 degrees will increase and the number of extreme cold weather will decrease in Yellowknife area. How this is relevant to my study? I'm interested to study lakes. In Canada, we have about 2 million lakes in different size and type. The timing of ice formation and ice, when the ice is formed and is gone, it's a very important indicator of climate variability and changes. So change in ice phenology, known as freeze-up, breakup time, extent of ice, and duration, affect lake heat budget balance and will really strongly affect the physical, biochemical processes, as well as ecological productivities of these water bodies. It also plays a very important role in climate regulations, bringing a strategic for resource and freshwater supplies. So, as a result of climate change, lakes in cold regions are rapidly changing and ice phenology processes will change with a very high rate. This will result in a variation in temperature and precipitation. With that, physical characteristic is changing of the lakes. However, this physical characteristic, as you can see here, are connected to geochemical or biological processes. So everything is connected to each other. Any changes in physical, in ice duration, and so on will impact geochemical and therefore biological processes. The system is very complex. So for this complex system, we need to study, so we need more smart way to first monitor it and then to understand it. Here come my research group, RESEC 3 years ago. So the idea of RESEC is to put multi-method approach to understand the ecosystem better in rapidly changing climate. We use orbital satellite remote sensing, we use drones and unmanned aircraft systems. So we are on the ground, so doing in-situ observations and in-situ monitoring. So trying to understand and investigate the physical and geochemical dynamics of lakes through a very interdisciplinary approach. So our research involves understanding the past, current, and future lake ice changes. So basically use lots of remote sensing and data in situ data tools, and we also use modeling physical and data-driven models like AI. And so why we do that? Because we believe none of these tools are perfect. The combination of techniques is the best approach to tackle the issues that we are facing today. One of the applications of our study is one of very important application actually is ice road safeties. There are a lack of knowledge in how the ice evolutions and variability will be in this changing climate. So we're trying to help community with that. With a total of 1,466 kilometers of winter roads in Northwest Territories reported by Department of Infrastructure, it's really needed to monitor these changes in a very smart monitoring way. So where we are at after 3 years. Now we can monitor lakes smartly using our multi-method approach, as you can see. Combination of ground-based ground penetrating radar, drones, and mapping the ice, snow on the ground, and thickness in very fast and also spatially over the area, different areas on lakes. We also are monitoring a real-time, every 15 minutes, lake ice evolutions in different locations, as you can see as a pin on the map. Some of these stations are located on ice roads. And we're actually having this year, we have a year-round stations on one of the lakes as a station, research stations. And what we found, so far we have found that ice growth rates and thickness are directly influenced by the short-term variability in air temperature and snow depths. And deeper lakes can be more sensitive to these short variability and changes. Studying under ice water quality, we observed dissolved oxygen levels progressively decrease in all lakes through the winter period. And in some cases, like Handa Lake, the result found that we have found that sometimes a full water column can have an anoxia situation. So from mid-April to end of the ice cover season, so which is a very important and stressful for species and fishes that living in the lakes. So. And also, of course, as mentioned, looking at satellite observations. So we look at more than 500 lakes in NWT since 1984 using satellite optical sensors and thermal sensors. We found that the greatest changes in NWT is happening in October, sometimes up to 5-6 degree differences over time. And we found that we have later ice freeze up happening and earlier breakup happening as well. So all this finding, all this putting all this sensors up on the ground and looking at the satellite observations still was not enough. And with all this finding, for us, it was important still to understand why these changes are happening more in some regions than others. So for that, we need traditional knowledge. So we connected, communicated, and we're also talking and met elders and youth, working with guardians, working side by side to understand the ecosystem even better and learn from traditional knowledge. So I'm so grateful that learned during a lot of knowledge learned through past 3 years. And I'm very much looking forward to working with the communities more. To exchange the knowledge and co-create a project together, listen to them and create a new project and work with them for a better decision making. And of course, I'm grateful for the team working together, collaborators and students, which I just show some of them. So lots of them working still in Ontario and some more in NWT, but the time is short, so I couldn't present all of them. And I'm happy to have more discussions later on in this panel today.
Great, thanks, Homa. And yes, to all of our attendees, if you have any questions, please enter them in the Q&A chat there. There's a couple trickling in. And for our speakers too, I'd encourage you to check the Q&A box before our discussion at the end, because there might be some detail specific questions that you can answer. Okay, with that, let's move on to our final speaker here, Miguel. Miguel, whenever you're ready, please take it away.
Thanks, Brandon. Okay, just let me share my screen. How's that, Brandon? Can you see?
Looks great, Miguel.
Okay, great. Thank you. So, hi, everyone. My name is Miguel Sioui, and I'm a member of the Huron-Wendat First Nation, as Brandon pointed out earlier. And my research focus has to do with Indigenous environmental stewardship. And I guess you could extend that to human dimensions of climate change, and other forms of environmental change as well. So in terms of my research that I'm currently working on these days, a lot of it has to do with Indigenous environmental stewardship and climate change adaptation and mitigation in Northern Canada. And today I'm going to talk to you about one project in particular, which is the Decho Collaborative on Permafrost. I'm working on this project with my colleague, Dr. Bill Quinton. And so I'll talk to you a little bit more about my role as an Indigenous scholar, environmental management scholar within this project. So for Indigenous peoples, in Canada, Northern Canada, but indeed across the world, their livelihoods and their subsistence are often directly dependent on land and water, and on relatively stable conditions on the land and water as well. And so Indigenous peoples, I believe, have direct insights into the various regional and local impacts of global environmental change, because they're often the ones that have to deal most directly with these impacts of climate change. And so they also consider that they have a special role as guardians or as stewards of the land as well. And I think that Indigenous knowledge systems have a very important role to play in terms of climate change adaptation and mitigation, but also in dealing with other forms of environmental change as well. And there's been growing interest in academia, and in Western science as well, that there's profound value in Indigenous knowledge systems and land-based practices as well, and that it's very worthwhile to incorporate Indigenous knowledge into climate change adaptation and mitigation, regimes and structures, not only in Northern Canada, but around the world. If you want more information about that, I would suggest that you get your hands on the most recent IPCC Working Group 2 report on adaptation and mitigation. So there's a very particular focus on Indigenous knowledge systems within that document, and it kind of shows the current state of where we are as a planet in terms of incorporating Indigenous knowledge. So in terms of this project that I'm working on, the Decho Collaborative on Permafrost, as both Jennifer and Homa have pointed out, there's been accelerated climate change in northern regions, including northern regions in Canada, and in the Northwest Territories in particular. And so my research takes place in the Decho region of the Northwest Territories. So it's in the southwestern Northwest Territories. I'll show you on a map just a bit later on. So this accelerated climate warming has led to widespread permafrost thaw and land cover change as well. And it's disrupted the hydrological cycle in the Decho and ecosystems within it as well. And Dene cultural traditions and activities, land-based activities that depend on this. So there's a growing awareness within the Decho that permafrost thaw is one of the region's main climate change impacts, and it's negatively affecting all dimensions of Dene livelihoods, regional economies, the health and well-being of the people, and their capacity and ability to keep performing or carrying out their sacred spiritual duty as Indigenous peoples in the form of their land-based activities within their traditional territories. And now the thing is that there's long been a lack of information on permafrost distribution, evolution, and landscape change as a result of all of this within the region as well. So currently there's an urgent need to develop and mobilize knowledge on permafrost thaw within the Decho, and to develop practical and customized predictive tools and strategies to allow these populations, these Dene populations, to adapt to permafrost thaw, and also to provide interactive training for decision makers within Decho First Nations communities and other land users and managers as well within the Decho region. And so this Decho Collaborative on Permafrost, or DCOP project, it came about in direct response to this need, right? So our overall objective is to generate a fusion of Western and Indigenous knowledge on permafrost, and to use this as a basis to co-develop these new predictive tools, decision support tools and indicators that are directly usable and understandable by Dene land users and managers, but also the leadership as well within Decho First Nations. So I'll show you where the Decho is on this map of the Northwest Territories. So Decho means literally big river. And so this is the Dene name of the Mackenzie River, in the Northwest Territories. But it's also the name for this region that I'm showing you here on this map. So it's a 185,000 square kilometer region, and it spans the southern portion of the Mackenzie River Valley and the westernmost portion of Great Slave Lake. In total, there's 9 First Nations governments or organizations, and together there's a regional body that represents, the common interests of these communities. And so this body is Decho First Nations. And so, as I was explaining a bit earlier, permafrost thaw is one of the most significant regional manifestations of climate change within the Decho, and it's affecting every dimension of Dene life and livelihoods within the region. So here's an image to show you the very rapid rate of permafrost thaw and resulting land cover change, in which forest turns into wetland as the ground surface subsides with permafrost thaw. So where the tarp is on the photo on the left, the plateau was about 50 meters wide in 2003. And as you can see on the photo on the right, it was all gone by 2020. So as the dacial climate warms, the permafrost continues to thaw. And so this means that the ice inside the permafrost melts and it leaves behind just water and soil. So we've collaboratively developed, or we co-developed, the research questions that you see here on this slide with the Dacho First Nations leadership, and also leadership within the individual, Dacho communities as well. So the research questions, and this is all based on the needs and priorities of the communities, right? Which I think should be a focus of research with Indigenous groups, or any scientific research that takes place on Indigenous territories. It's really critical that the research is developed in tandem, right, with Indigenous partners. So the questions are, well, the first one is, where is permafrost located within the Dacho and where is it thawing? Question 2, what is the rate and pattern of permafrost thaw? Question 3, how is permafrost thaw changing the land? 4, how is permafrost thaw changing the flow and storage of water on the land? 5, what is the long-term trajectory of thaw-induced change to the land and water? And so I would say that these first 5 questions here, they have to do more with the physical science hydrology that's done by Bill Quinton, my colleague, and his team of graduate students. Question 6 really is, I think, what I'm most interested in as an Indigenous scholar, and it's what adaptation mitigation measures can or should be taken, right? And so for question 6, this is really where we combine Western science and Indigenous knowledge. And my role is to make sure that the science that's being done is reflecting Indigenous priorities and Indigenous knowledge systems, but also to translate, the results of the scientific research into a terminology and vocabulary that's usable by community members and community leadership as well within the Dacho. So in terms of documenting Indigenous knowledge about the state of permafrost and even climate change more broadly as well, I've been conducting interviews with land users and elders within the communities, holding focus groups and meetings and on the land camps to share scientific findings and DNA knowledge about permafrost thaw and climate change knowledge. And one particular tool that I find really interesting, and it's been, I believe, quite successful so far, is the creation of the All Ages, All Voices podcast, which is hosted and produced by a Dacho First Nations member in Fort Simpson, or the Liquay First Nation. And so the podcast is called All Ages, All Voices. You can find it on Spotify. And so this is really an important tool, I think, in spreading awareness about permafrost thaw and climate change in the region, and also sharing scientific information, scientific results, from the studies that are conducted there, and also Indigenous knowledge, right, by interviewing elders and community leadership and having them come on the podcast and share their knowledge, especially elders, because they have multiple decades and they've experienced changes on the land, within a longer time frame. I think that it's very useful in terms of a tool in spreading awareness about permafrost thaw. So the outcomes of this research are to assist in building greater community leadership in research, in the scientific research that goes on within the Dacho, better coordination in the form of training, monitoring, and research, to produce new high-quality data sets, adaptation strategies, as well as predictive tools and capacity, and also to establish or create a data archive or portal that can be used by Dacho First Nations communities. And finally, new predictive tools and capacity. So I'm going to finish up by talking a little bit about the future outlook on the role of Indigenous knowledge in climate change adaptation. I would say that even looking beyond the Dacho and the Northwest Territories, and even Northern Canada for that matter, as a global society, given our successive and consistent failures in adequately and effectively responding to climate change, it's become really urgent for the human collective around the world to learn from all other knowledge systems, other forms of knowledge, and I would argue Indigenous cultures and Indigenous knowledge systems that remind us about our responsibilities as human beings to the land, and that will, I believe, allow us to reorient our societies to better respond and react to changes like climate change, right? The wicked problems that we're faced with today in terms of humanity as a whole. So I think, and actually I firmly hold that this process of learning about Indigenous knowledge systems from Indigenous peoples themselves could foster the development of climate change policies that promote more respectful and responsible relationships with the land and the water, right? The environment over the long term. So I think that it's really necessary to, to employ an all hands on deck approach to climate change adaptation and mitigation, where we can't rely solely on Western scientific knowledge and studies. We really need to use all of the different forms of knowledge that are available to us. And Indigenous peoples have been on this continent, like talking about the Americas, since time immemorial, right, for thousands and thousands of years. So there is indeed, tremendous value in their knowledge systems, languages as well. It's very important to preserve and to protect Indigenous languages. Indigenous peoples make up about 5% of the world's population, and they manage over 80%, perhaps even 85% of global biodiversity. When we're talking about boreal forests here in Canada or the Amazon rainforest in South America. So allowing Indigenous peoples to continue to be the stewards of their lands, their territories, as they've done for millennia, I think is a very, very important aspect in terms of climate change policy. So I'll end on that note. Thank you very much.
Great. Thanks for sharing, Miguel. I mean, it's really nice to see how your work aims to bridge the gap between our, academia world and Western science and Indigenous communities and the knowledge that they have, which, isn't something that we often associate with science, but, these people have lived on the land for hundreds of thousands of years, right? They have observations, and whether or not they have, data recorded to back it up doesn't mean they're any less important, right? I mean, I've experienced that myself too, working with Northerners and Northern communities, and that's great. Yeah. So thanks to all our panelists for sharing a little bit about what they do and where they work and the communities they work in. So we're going to open it up now for some questions. And we've had some questions answered in the Q&A chat already there. So if you have a question for a specific presenter, something more technical, maybe enter it in the Q&A chat. And then we'll have a little discussion here on some of the broader questions there. And we actually just had a question that popped in the chat here. So I think we'll start off with that one. So this is from an anonymous poster here, but what are the biggest barriers to incorporating traditional ecological knowledge into policy? That's a great question that I was actually going to sort of follow up with one of my first questions. So that's great. So maybe, I mean, let's start off with Homa. I know Homa, you have quite a background in using science to advise and develop policy. What's your experiences with, trying to incorporate traditional knowledge into scientific or political policy?
Very good question, and I think it is very important to really connect the knowledge, not only traditional, also Western knowledge to policy. I mean, both parties are missing the connection between policy, but communication is the first thing, because I think the dictionary and the way that policy talks is very different to either of themselves Western or traditional knowledge, and we are not there yet. We are not communicating. We need more events to sit together and talk with politicians, and we should bring Indigenous leaders on the table with the scientists, Western scientists and politicians together to make sure first we have that communication. So we need more events like Science Meets Parliament and to bring and science to the policy. So it's actually first time this year Science Meet Parliament's actually events adding Indigenous researchers actually to the pool of people invited to the government. So I think that's a very good step to bring all together and to have the communication. I think communication is one of the main part that it's missing. So.
Yeah, thanks, Homa. Jan or Miguel, anything to add?
I guess I would just say, all of these things take a really long time. And, when you think about knowledge that is created, whether it's knowledge that's created through scientific Western science processes or knowledge that's, held in communities, it's a really slow process getting that actually translated into something that takes the form of policy. And I think it requires a lot of steps in the middle, working with managers, whether it's in Indigenous governments, whether it's in territorial government, whatever, to start to use the information that we're gathering or that we hold to help inform management and decision making in those areas. And then, as that starts to show promise, then you start to get to a point where maybe there's some inkling that it will eventually become something, down the road in the context of policy. I think an immediate translation from science or Western science or traditional knowledge into government policy, there's a lot of steps in between there that we don't talk about those steps enough. And I agree with Homa, it's that communication, but it kind of has to happen through a slow process. And so, yeah, that would be my 2 cents there.
Thanks, Jen. Miguel, any comments on that?
Yeah, actually, I think, I echo what Homa and especially Jennifer, have said. It's a very slow going process, and I think it depends kind of unfortunately, on proving in some way that Indigenous knowledge has value, which comes down to, I think, past experiences, legacies of colonialism in Canada and elsewhere, in which Indigenous knowledge systems were considered as, invalid or as inferior. And I think that has to change, and it is changing. When you have international bodies like the United Nations and the IPCC recognizing the importance and the valuable role that Indigenous knowledge systems are playing in this equation, right, in terms of climate change and other forms of environmental change, then I think that things are going to start changing for the better in that sense. Yeah,
I agree, and yeah, that's sort of Miguel, a perfect segue into this next question, talking about the colonial nature of research, at least historically in northern areas like this here. I was just having conversations with some of my connections in Inuvik this last week, and I talked about highlighting the extractive nature of what we do as southern researchers in the north. Right, you go up, you collect your data, you go home, and historically, nobody ever saw the results, or nobody ever heard what came of it, right? And it's their own backyard, right? And so there's this sort of old school way of having extractive research, and I would say, hopefully, at least it's changing, especially with early career researchers being trained differently, right? And science pivoting a little bit to incorporate some more. It's not perfect, but I think there's a push to try to do that. So, but the longstanding effects of that are the same. You talk to elders in the communities, and they talk about working with researchers decades ago and how different they did stuff. So what kind of barriers, as a result of some of these historic ways in which Western science has been conducted, like how do you identify and move past those barriers, right? How do you bridge that gap between trying to move forward with incorporating more traditional knowledge or community involvement in project development when there is a bit of a historic legacy from Western science.
Since no one else is jumping in, I'll speak up. I think, I think part of it just is a function of, showing up and sharing and, spending time and talking with folks and developing relationships with folks in different communities. And I mean, that's the case, whether you're, in the Northwest Territories or whether you're in Ontario doing research. I think, you need to develop relationships with the partners that you're working with and develop, develop that trust so that you can, work more effectively with those folks. And I think I'm going to leave it there for this a second. I'll pass it over to one of my colleagues. I had some other thoughts, but they seem to have vanished at the moment. So I'm going to let Homa or Miguel jump in here.
Go ahead, Homa.
I would say as someone who works in remote sensing and modeling for a long time before joining Laurier. So definitely perspective of someone that run models or use satellite observations. Looking at the screen basically is what I needed to do my research, and I was successful. I'd done it, and it was good. So here I am. But joining Laurier, and it was really a game changer to make sure that what I do and what I see on a screen is connected to the land. So traditional way of Western science is I do the science for answering my scientific question, of course, to help the science community, also my own merit as well. And now I think learning that you do it for the impact to the community and make sure in a regional scale, which is different from the global scale as mentioned in my presentation. So the scale is different. So we cannot generalize everything in a global scale and ignore the regional scale and the impact that people are actually having every single day on the ground. It takes time. Someone that done that different way 3 years ago and doing it now, it takes very much time to connect, be there. It's not helping with the academic merit that we usually have. So it's not helping for me to publish more. It's because I spend lots of time logistical things being on the ground. So usually Western science is not see that effort and is not seeing that much of time that need to be spent. But I'm very hopeful that moving forward, so we can do more. But still, I hope that we can have more merit of being on the ground rather than being on screen, and somehow we can actually put it in balance, which for my research is in balance because it's a lot. So it's a lot to do both at the same time, which I'm not going to give up. So it's hard, but I'm sure it's going to be a time that we can actually balance it out. So I leave it there.
Yeah, maybe I'll add a few thoughts on this. I think Homa really hit the nail on the head. It takes time to build these relationships. It takes effort and time, right? And those priorities don't necessarily coincide with the priorities of scientific research, unfortunately. But things have to change. I mean, the fact is that as researchers, Southern researchers doing research in Northern Canada, we're guests, right, on Indigenous territories. I wouldn't show up to someone's house and try to rearrange their furniture and to act as if I run the place, right? We have to humbly accept our role as guests and as allies and work according to the priorities and the needs of Indigenous communities, our Indigenous research partners. So I think it's a matter of humility as well, and making sure that the research that takes place follows Indigenous protocols, Indigenous research methodologies. There's a growing literature on that. So it's the responsibility of every researcher, both Indigenous and non-Indigenous, to make sure that they're familiar with Indigenous research methods and protocols, and how to be a good guest, basically, in someone else's house.
Yeah, Miguel, that's a great way to put it too. And, and like touching on both what you and Homa and Jen have said, I've been a Northern researcher for almost a decade now at all different levels, and it takes a lot of time to build those community relationships. And us, in the South, we have other obligations and teaching and, all this other stuff going on, and the communities and the members that we work with, like they live there, right? They're there all the time. And so they, can benefit scientific knowledge quite a bit by observing what they and recording what they see right in their own backyard. And at least in our field, in my group, and we try to look at little ways to help boost that and build capacity for them to monitor what they're interested in. And sometimes that benefits us, and sometimes they just can pass that knowledge along. And yeah, so it's great to develop these communications. Okay, so we're just at the end of our time here, but before we closed up, I know there's a few unanswered questions. So for all the panelists, if you can take a look through there and maybe give those a check. But we have one question here we'll close up with, and it's actually for Jen from Evan. So what are the next big questions that you're curious about understanding the response to boreal forests to fires under a warming climate change? What are the next big steps, I guess?
Yeah, thanks, Brendan, and thanks for the question, Evan. So one of the things I didn't touch on today, given time constraints, is the fact that we're seeing actually a fairly high amount of post-fire regeneration failures. So across boreal North America, we're seeing about 10% of sites that we measured not regenerating to any kind of forest type. And so I think there's a really big need to understand what's driving those successional failures, and will those sites stay in that non-forest state? Is it going to be some kind of arrested succession situation? We often see shrub thickets recruiting into those places, or dense grasses. A second piece, and this is something we're doing and we're working on in partnership with the fire management group here in the Northwest Territories, is understanding overwintering fires. So as our fire seasons get longer, burn later into the fall, we're seeing, and we have more of these big fire years. These big fire years are linked with fires that not only burn through the fire season, but then burn through the winter and reignite the following spring. This causes big challenges for fire managers and for communities near those fires. And we don't really understand the ecological implications of those kind of 1-2 punch type fires. So those are a couple of key things. And then really, some of the next steps of some of the work we're doing is translating the findings that we've gotten from some of this fire-based research to really start to address place-based, community-driven questions about, in the areas that burned, what are the implications in that place? And there's the communities that we're working with have lots of very specific questions that we're trying to lend our data, lend our insights to help to address. So those are kind of 3 things that we're moving forward on at the moment.
Great, thanks, Jen. And yeah, with that, I think just for the sake of time, we'll wrap it up there. I want to first thank all of our panelists for joining and sharing their research, and thank you to all of those that attended. If you have any further questions, I'm sure there's many different channels that you can follow up with our speakers, whether it's through social media or email, or just reaching out to the university and trying to connect with these. So yeah, with that, I'd like to say thank you for thank you for joining for this Laurier inspiring conversation. And I wanted to just real quick while we wrap up, promote the next talk, which is in the new year on January 24th, titled The Hunger Games: Understanding How Exercise Affects Appetite Regulation. And with that, thank you, everybody, and have a good day.